Hello and welcome to the video notes for lessons 4, 6, Triangle Congruence, CPCTC. We'll explain what all this means here in just a moment. As always, please make sure you've read through lesson 4, 6 in your textbook so you could fill out the vocabulary for this lesson ahead of time. And make sure that you've done the vocab in the vocabulary notebook. Once you have those done, go ahead and take a look at the warm-up. Go ahead and try and answer these 4 questions as your warm-up, and we will check our answers in just a moment. Alright, if you need more time, go ahead and pause the video. Most of you will probably need to do that. But if you are ready to begin, you can click play, and let's check out our answers. Number 1, if these triangles are congruent, angle A would be congruent to angle D. And side BC would be congruent to side EF. What is the distance between 3, 4 and -1, 5? You'll have to use the distance formula. Remember, that's where you find the difference of the x-coordinates, 3 minus -1, or 3 plus 1 is 4. Square that, and find the difference of the y-coordinates, and square that, then add those together and take the square root. You should get the square root of 17. If you evaluated that, that's fine, but you should have had the square root of 17. Alright, if angle 1 is congruent to angle 2, why is A parallel to B? By the converse of the alternate interior angles theorem, or the alternate interior angles converse. And lastly, want to list the methods used to prove two triangles are congruent. Side, 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 angle, angle, side, angle, 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 side, hypotenuse, leg, and then you could have also written definition of congruent triangles, but most of the time we will not use that now that we know these shortcuts. Here's the objective today. We're going to use CPCTC to prove parts of triangles are congruent. Your vocabulary is that acronym, CPCTC, and we will explain what that means here in just a moment, but first let's take a quick review of the previous 2 lessons. I want you to take a look at these 9 situations and tell me yes or no, are the triangles congruent? If yes, you need to be able to state why. Side, 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 angle, 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 side, or hypotenuse, leg. Take a few minutes, pause the video so that you can get these answered, and then we will review our answers together. Alright, we're going to go ahead and continue. Hopefully you have all 9 answers, or at least the ones you're sure of. These 2 are congruent by side, side, side because of the reflexive property here. These are also congruent by side, side, side for the same reason. We have a reflexive property making these shared sides congruent. These are congruent by side, angle, side. But in number 4, we don't have enough information to tell if they are congruent or not, so your answer should be no. Number 5, hypotenuse, leg makes these congruent. Number 6, not enough information, no. 7 is also not enough information because the wrong sides are congruent. We don't have these 5mm sides matching up. They're not corresponding. And number 8, yes, those are congruent by angle, side, angle because of these vertical angles here. And again, number 9, we don't have enough information. No, these are not congruent. Even though M is the midpoint, I don't know the hypotenuses are congruent. I also don't know these other sides are congruent. Alright, let's talk about what CPCTC stands for. It's an abbreviation of this phrase. Corresponding parts of congruent triangles are congruent. And that's what you should write down. Corresponding parts of congruent triangles are congruent. CPCTC. This can be used as a justification, or a reason, rather, in a proof after you've proven that 2 triangles are congruent. But you must state that the triangles are congruent first before using this for a further step. Remember this, side, 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 angle, 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 side, and HL use corresponding parts to prove the triangles are congruent. CPCTC uses congruent triangles to prove corresponding parts are congruent. So let's take a look at example 1. We're going to give some explanations of why things are the way that this problem says they are, and we're going to find values. We have a landscape architect setting up the triangles shown to figure out the distance across this pond. That would be JK. So he set up the triangles here. So let's figure out what is JK. Well, here's what we know. This segment is 30, and then the other side is 30. This segment's 19. This side is 19. That means L is the midpoint of both of these sides. So we have congruent sides here and here. here and here, but these vertical angles are congruent. So these two triangles, top and bottom, are congruent triangles by side, angle, side. If the triangles are congruent, then the corresponding parts are congruent. What part corresponds to JK? That would be MN. Since MN is 41 feet, JK should also be 41 feet. One angle pair is congruent because they're vertical angles, like we said. Two pairs of sides are congruent because their lengths are equal. Therefore, the two triangles are congruent by side, angle, side. By CPCTC, the third side pair is congruent, so JK is 41 feet. Let's see if you can set up a similar explanation here. We have the given measurements of these two triangles. A and B are on these opposite edges of a ravine. So to find that length, we want to be able to show that the triangles are congruent, so their corresponding parts can be congruent. All right, you should have something like this. One angle pair is congruent because of the vertical angles. Two pairs of sides are congruent because their lengths are equal, once again. So the triangles are congruent by side, angle, side. By CPCTC, the third pair of sides are congruent, so AB is the same as this side over here, which is 18 miles. All right, now we're going to take a look at actually working out some proofs using CPCTC. Before you can use CPCTC, you have to have proven that triangles are congruent. So we will still use SSS, SAS, ASA, AAS, and HL to prove triangles are congruent, but then the step after that will be that there are specific parts congruent by CPCTC. So here's what we're given. We're given that YW bisects XZ. So this vertical segment is a bisector of the horizontal segment. So that will tell me that I have congruent segments here and here. And you're given that XY and ZY are congruent. So I have congruent segments here. Well, they share the side YW, so those are congruent. So we will be able to prove the triangles are congruent by side, side, side. And since the triangles are congruent, their corresponding parts, angle XYW and angle ZYW, would have to be congruent by CPCTC. Once again, this is what you should say. Start with that first given. YW bisects XZ, which is given. That tells you that XW is congruent to YW by definition of bisector. So there's a pair of congruent sides. Next, XY is congruent to YZ because it's given. There's another pair of congruent sides. And then YW is congruent to itself by the reflexive property. There's your third pair of congruent sides. So these three, steps 2, 3, and 4, show side, side, side congruence. That means the triangles are congruent by side, side, side. And if I have triangles that are congruent, remember this. Corresponding parts of congruent triangles are congruent. Well, XYW, and ZYW are corresponding parts of these two triangles. So we can say XYW is congruent to ZYW by CPCTC. Let's take a look at example 2b. We want to try and prove that PQ is congruent to PS. Those are corresponding parts of these two triangles, so the first thing we must do is show that these two triangles are congruent. So let's look at the given information. We're told that PR bisects both of these angles, QPS and QRS. That means angle QPR and angle SPR, this top angle on the left, this bottom angle on the left, they have to be congruent, as well as QRP and SRP, the top and bottom on the right, those have to be congruent because that's what bisector means. So if these angles are congruent and these angles are congruent, and we share side PR, so I have congruent segments by the reflexive property, the triangles can be congruent by angle, side, angle. So let's look at doing that in a proof. First statement. PR bisects angle QPS and angle QRS. That's a given. So the next statement, we're going to explain what angle bisector means. That means angle QRP and angle SRP, top and bottom on the right, are congruent. And these two on the left are congruent, QPR and SPR, by definition of bisector. So I have congruent angles here and here, and congruent angles here and here. The included sides between both pairs of congruent angles are the same side, PR. So I can say RP or PR is congruent to itself by the reflexive property. So what we've shown is that triangle QPR is congruent to triangle PSR by angles, side, angles, or angle, side, angle. Since these two triangles are congruent on top and bottom, their corresponding parts are congruent. So PQ is congruent to PS by CPCTC. Here's a helpful hint. Work backwards when we're planning a proof. To show that, for example, ED is parallel to GF, look for a pair of angles that are congruent. So we can use alternate interior angles converse, or same side interior angles converse if they're supplementary, or something like that, so that we can prove the lines are parallel. Then look for the triangles to contain these angles. So here's what we're going to do. We are going to prove that MN is parallel to OP. And this is a little bit tricky. In order for MN to be parallel to OP, I need opposite angles here and here to be congruent. In order for those to be congruent, it'd be nice to say that these two triangles are congruent because these are corresponding parts. So in order to say the triangles are congruent, I'm going to use the given information. Well, they tell you the top and bottom are parallel, so I get a different pair of congruent angles by alternate interior angles theorem. And we're told that angle N and angle P are congruent. And then we still have a shared side. So the goal is to say that triangles are congruent so that we can say their parts are congruent by CPCTC. And then because of those parts being congruent, the lines are parallel. So angle N is congruent to angle P. That's one of the givens. Here's the other given. So we have one pair of congruent angles. Here's another pair of congruent angles by the alternate interior angles theorem. NOM and PMO. And then we have MO is congruent to itself by the reflexive property. So the triangles are congruent by angle, angle, side. Two angles and a non-included side congruent to two angles and another non-included side. Because these triangles are congruent, their corresponding parts are congruent. That's what makes angle NMO and POM congruent by CPCTC. And because these two angles are congruent, these sides are parallel by the converse of the alternate interior angles theorem. Let's see if you can try and do a similar proof on your own. Remember, the last step is this. Before that, I want to show that angles are congruent by CPCTC, so that the converse of the alternate interior angles theorem will make these parallel. Alright, if you need more time, pause the video. Otherwise, we are ready to continue. If J is the midpoint, and that's given, then definition of a midpoint tells us we have congruent segments KJ and MJ and NJ and LJ. That means we also have angles at J here on the left and right that are congruent by the vertical angles theorem. So these triangles, KJL and MJN are congruent, the top and bottom, sorry, top and bottom, not left and right. Those are congruent by side angle sides from steps 2 and 3. That means their corresponding parts are congruent. If I'm talking about the top segment and bottom segment to be parallel, that means I'm looking for either an angle here at L or K to be congruent to an angle at N or M. So we pick LKJ to be congruent to NMJ, and those are alternate interior angles, so these lines are parallel by the converse of the alternate interior angles theorem. Okay, there's one more problem here, and in order to do this problem, this is going to take several steps. So before we go on with this, if you'll notice and look down at the time, we only have 15 minutes in each video. In order to do this completely, there's going to need to be a second video. So you may have noticed there were two different videos. The second video is only going to be example 4. I do want you to go ahead and fill that one out, so you'll need to watch the next video to figure out example 4, how to use CPCTC in the coordinate plane.